Hello, geometry, and welcome to your first lesson of semester 2. If you're new to my class, this will be your first time watching video notes, probably. Uh, what you want to do is you want to follow along, and you have this paper that's showing on your screen right now in front of you. You should, and you just want to fill in the missing spots and write down any questions you might have as I go through it. The expectation is that you do pay attention and that you try to understand it. If you don't, that's what tomorrow's for. Tomorrow we're going to go into this and figure anything out that you didn't understand. Okay, so here we go. The learning targets. I want you to identify the trig ratios in right triangles and find side lengths in right triangles using trig. So this beginning here is going to probably confuse you a little bit, but it'll clear itself up, I promise. Maybe not in this video, but I'll get it figured out in class. So in any right triangle, there's one right angle. So in this picture, it's angle C. And two acute angles. So in this picture, it's angle A and angle B. In the trig we will be looking at today, you must have a right triangle. But the trig ratios are found with respect to the two acute angles. So you need to identify that it's a right triangle by looking at angle C, but then what we're going to be looking at is a bunch of stuff that's attached to angle A and angle B, okay? The three trig ratios we're going to look at today, there are 6, but we're going to look at 3. Sine, it's abbreviated SIN. I have a lot of people say sin. It's not sin, it's sine. Cosine, looks like cos, COS. And tangent looks like tan. Okay. Those are the 3. You see those on your calculator, well, most of your calculators. Yeah. So each of these trig ratios refers to ratios of certain sides. Oops. Not sure why it's doing that. Sorry. Each of these refers to ratios of certain sides of the right triangle with respect to a certain angle. All right, so it connects. Yeah, I'll keep going here just to show you what I'm talking about. The sine of angle A, written looks like sin A, but that's the sine of angle A, is the ratio of the length of the opposite side of angle A over the length of the hypotenuse. So if I'm looking at this picture up here, angle A, which side is opposite angle A? That would be little a there. So it's A over the length of the hypotenuse. Well, in this case, the hypotenuse is C, right? So A over C. The sine of A equals A over C. All right. Here's what the trig ratios say. The sine of an angle is always the length of the opposite side of that angle over the hypotenuse. The cosine of an angle is always the length of the adjacent side. Over the hypotenuse as well. I'll abbreviate to hypotenuse. The tangent of an angle is always the length of the opposite side over the adjacent side. And I'm going to do adjacent as ADJ. Okay, so what I'm going to do now is I'm going to clear that. Let's scroll down here a little bit. We're going to write the trig ratios of each of these figures. Okay, try and make it so it shows up a little nicer in your screen. I know it's split screen right now, but what we're going to do is we're going to look at the sine of A. We already did that one. So the big A is telling me I'm looking at that angle. So when I'm looking at A, what is the opposite of A? Little a. And what is the hypotenuse? C. So A over C is what goes here. The cosine of A is, so I'm again looking at A, and then I look at the cosine is the adjacent side over the hypotenuse. So which side is adjacent to A? Well, C is, but so is B. There's two sides that are adjacent, but C is the hypotenuse. So we want to leave C as the hypotenuse. That leaves B as my adjacent side and over the hypotenuse of C. Okay, the tangent of A, again, looking at A, is opposite over adjacent. So opposite is A, and adjacent is B. I'm going to switch colors now so that you can see it's a little bit better. Sine of B. Now I'm switching what I'm looking at. I'm looking at angle B. What happens there is B, the opposite of B, is little b. The hypotenuse doesn't change. That's still C. The cosine of B is adjacent over hypotenuse. So adjacent to B is A, and the hypotenuse is C. And then the tangent of B is opposite over adjacent, so B over A. Okay, now I'm going to blow this up a little bit so you can see it a little bit better. Okay, I'm going to go ahead and clear it. So I had sine of B was B over C. Cosine of B was A over C. And tangent of B was B over A. And I had the other ones were A over C, B over C, and A over B. You can rewind it to make sure I'm not making that up. A couple things I want you to notice, and this is why I rewrote them. The sine of an angle is equal to the cosine of the other angle. These are just some relationships I'd like you to see. So the sine of A is equal to the cosine of B. Look at them. They're both A over C. And the sine of B is equal to the cosine of the other angle. So the sine of A, or the cosine of A. They're both B over C. Another thing I want you to see, the tangent of a particular angle is the reciprocal of the tangent of the other angle. Look at these two. One is A over B, the other one's B over A. And that's because when you look at one angle, a certain side is opposite. If you look at the other angle, that same side is then the adjacent. So the opposite and adjacent kind of switch spots. That's why these things happen. Okay. There's an acronym that we often use to help us remember these trig ratios. You will hear me say it a lot. It's SOHCAHTOA. You say that to any geometry teacher, they will know what you're talking about. Okay. Write each trig ratio from the figure below. Before I do that, I'm going to talk about what that word means. SOHCAHTOA. So S tells you the trig ratio. So that's sine. The first letter in each little three-letter thing is the trig ratio. So sine, cosine, tangent. And then it tells you the next two letters tell you the ratio. So O is opposite, H is hypotenuse. A is adjacent, H is hypotenuse. O is opposite, A is adjacent. If you remember that, you have all the ratios right there in front of you. All right, so we're going to write the trig ratio from the figure below. You must always reduce your ratios and put them in simplest radical form. Okay, no radicals in the denominator. So first thing we need to do here is we need to find the length of AC by using the Pythagorean theorem. So 10 squared plus the missing side squared equals 15 squared. So that's 100 plus x squared equals 225. Subtract 100, I get 125. You did this plenty in first semester, so I'm not going to spend any time talking about what the square root of 125 is. It is 5 radical 5. So the length of AC is 5 radical 5. I'm going to go ahead and get rid of that work because I'm going to need some space to do the remaining parts. All right, the cosine of B. So I'm looking at B now. My right angle is A, so I'm looking at B and C. I can't look at A. The cosine of B is adjacent. So adjacent to B is 10. Actually, you know what? Cosine of B is 10 over the hypotenuse is 15. But I can reduce that to 2/3. The tangent of B is the adjacent side over the adjacent side. So opposite over adjacent. So 5 radical 5 is opposite. Adjacent is 10. I can reduce the 5 and the 10 to 1 and 2. So 1 radical 5 over 2. The sine of B is a opposite. So 5 radical 5 over the hypotenuse, which is 15. And again, I can reduce that. That's the square root of 5 over 3. Right. I'm going to switch over to C now. Okay. So the cosine of C should equal the sine of B, but let's just look at it. Cosine of C adjacent to C is 5 radical 5 over the hypotenuse is 15, which reduces to square root of 5 over 3. The tangent of C is the tricky one here. It's the reciprocal of the tangent of B, but that's going to look weird. So it's going to be 10 over 5 radical 5, which reduces to 2 over the square root of 5. But I set up here in the directions, no radicals in the denominator. So how do I get rid of that? You may remember this from Algebra 1. I call it multiply by fancy 1. I'm multiplying the top and the bottom by the square root of 5. What that does is it gives me 2 radical 5 on top. And on the bottom, it becomes a square root of 25, which is 5. So the tangent of C is 2 radical 5 over 5. And then the sine of C is opposite over adjacent, or sorry, opposite over hypotenuse. So 10 over 15, which is 2/3. Okay. I said this at the very beginning of doing these ratios, but one thing I do want you to notice, we never have trig ratios with the right angle. Why is that? A couple things I've seen. The side opposite angle A is also the hypotenuse, right? So what do you call it? Do you call it the opposite or do you call it the hypotenuse? There's confusion there. Also, there's 2 sides adjacent to angle A. Which one are you going to use when you're doing these trig ratios? We never do the trig ratio of the right angle. Okay. Now, what you're going to see, spend a lot of time getting into that, but what you're going to see is more what 1 through 4 is here. We are going to find missing side lengths, and with the next unit or with the next lesson, we're going to find missing angle measures using trig. I want you to write the equation and then solve it. Okay, so you're going to have decimals, you're going to need calculators. All right, so if you don't have a calculator, get one ASAP. All right, so what I'm doing here is I'm looking, I have 53 degrees here. I see that. And then I see that I have the side opposite and I have the hypotenuse. Okay, so I have the opposite and the hypotenuse. Which trig function deals with opposite and hypotenuse? That would be sine. So I say the sine of the angle, and the angle here is 53, equals the opposite side, x, over the hypotenuse, 15. That is the equation that I want you to write down. Now, what you do to solve it, I want to get x by itself, is I just going to multiply both sides by 15. So x equals 15 sine 53. Well, the sine of 53 is just a number. This is where you just go to the calculator, you type 15 sine 53, and you should get 11.97. It says round to the nearest tenth. So 11.97 rounds up to, so 9 goes up to 0, but that becomes 12.0. Okay. next one, number 2. Again, I'm looking at the 25-degree angle. I have the side opposite, and I have the adjacent side. I do not have the hypotenuse. Which trig function deals with opposite and adjacent? That would be tangent. So the tangent of the angle, so tangent of 25 equals the opposite side, b, over the adjacent side, 8. So that's my equation. I'm going to multiply by 8. So I get b equals 8 times the tangent of 25 degrees. So 8 tangent 25, type it in your calculator, you get 3.73, which is 3.7 to the nearest 10th. All right. 2 more. This next one is a little tricky because it looks like it should be, you have options here. Looks like you have sine of 53, or you could do tangent of 53, except we're making an assumption here, and you need to be very careful about this. There's no right angle. We can't do this one right now. That's not, it looks like a right angle, but we don't have that as a right angle. We can't do this one right now. Okay, last one. You've got 2 variables here, so you have 2 equations. I'm going to use the 30-degree here. Let's do A first. So I don't want to do A and C. I want to do A and 7. So I've got A and 7. So that's adjacent and opposite. So that deals with tangent. All right, so the tangent of 30, and this one's going to be tricky because the opposite is a number and the adjacent is the variable. This equation right here is one of them that you would want to write down. This one is tough to solve because you have the variable on the bottom. So I'm going to do this in 2 steps. So notice what I did. I always multiplied by the denominator, even if it's a variable. Okay, that doesn't solve for A yet, though, because I need A by itself. Well, the tangent of 30 is just a number. If you type it in your calculator, you will get a number. So I'm going to divide by that number, tangent 30. So A equals 7 over the tangent of 30. So I'm going to type that now in the calculator. 7 divided by tangent 30. I get 12.12, so 12.1. Okay. That same thing's going to happen when I do C. I'm going to use 7. I don't want to use 12.1 because that's a rounded number. If I can use a whole number, I want to do that because that's going to give me a closer to my actual answer for C. So 30, I'm looking at now opposite and hypotenuse. That's the sine. So sine of 30 equals 7 over the sine, or sorry, 7 over C. Get ahead of myself here. Multiply by C. I get C sine 30 equals 7. Divide by the sine of 30. And whatever 7 divided by the sine of 30 is my answer. So 7 divided by sine of 30, I get 14 exactly. Okay. And that's it. I know it's probably pretty confusing, but that's lesson 1. We'll have time to go over it in class before moving on to lesson 2.